Let us see some more questions from the same exercise 15.1 of circles of class 9. In this question we have the length of the common chord, that's common chord of two intersecting circles. That means the two circles intersect at 2 points and the common chord is 30 centimeter. And the two circles are of radii 25 centimeter and 17 centimeter respectively. Now let the center of the circle with 25 centimeter be A, 25 centimeter radius, and B the center of the circle with 17 centimeter radius. And let CD be the common chord with the length 30 centimeter. So what you need to do is draw a perpendicular bisector of CD at M. Okay. So in the figure we can see the blue circle with the radius 25 centimeter and the orange circle, the smaller one with radius 17 centimeter. Okay, they are intersecting each other at the points C and D, and the common chord length CD is 30 centimeter. Okay, now if we draw a perpendicular bisector of the chord CD at M, so that perpendicular will always pass through the center of the circle, right? Perpendicular bisector of a chord passes through the center, so it will pass through both the centers A and B. Now we need to find the distance of AB. We know the length of CD, so length of CM is half of CD, it should be 15. So now if you see the two right angle triangles, you can easily find the length of AM and BM using Pythagoras Theorem, and then we can add it to get the distance AB. So the perpendicular bisector of CD will pass through centers of both the circles, and AB is the perpendicular bisector of CD. Okay, using the Pythagoras theorem in both the right angle triangles, so actually CM is half of the chord length 15 centimeter. So in right triangle AMC, using Pythagoras theorem, we can find AM equals to 20 centimeter, and in the other right angle triangle BMC, we have BM equals to 8 centimeter. So the total distance between the two centers will be the sum of these two, so that's 28 centimeter. In this question we have an equilateral triangle, and we have to prove that the centroid and the circumcenter of the triangle coincide with each other. Okay. So what is centroid? Centroid is the point of concurrence of the medians. Okay, so the intersecting point of the medians is centroid, and the intersecting point of the perpendicular bisectors of the sides of a triangle is called circumcenter, because this is the center for the circle which goes through all the vertices of the triangle. Okay, so we have triangle ABC is a equilateral triangle, and then the construction you need to do is draw the medians, and then we are going to prove that these medians are also the perpendicular bisectors of the sides. You can also do it in the other way, like if you draw the perpendicular to the sides of the triangle, then you need to prove that those are not only perpendicular, are also perpendicular bisectors, so that you can say they are medians. Okay, so we'll start with the median part here. So let AD, BE are the two medians from the vertex A and B for the triangle. So D will be the midpoint of BC and E will be the midpoint of AC. Let us see the figure. So in the figure we can see triangle ABC is equilateral with all the sides equal. We have drawn the median AD and BE. So these are the two medians. Of course the third median CF will pass through this intersecting point P only. So it is not required to take all the medians. We can take two medians and find the intersecting point. Now we need to prove that these two are also perpendicular bisectors of the sides. AD and BE are the medians, so they intersect at the point P, which is known as centroid. Okay, so in triangle ADB and ADC, we can see that AB and AC are equal, BD and CD are equal, AD is common, And so triangle ADB is congruent to triangle ADC by side congruency criteria. Okay, so thus angle ADB and angle ADC are equal. This is important because this proves that they are 90 degree. Now they are equal because they are corresponding parts of congruent triangles CPCT. So we know that they are linear pair, so the sum is 180 degree, and hence ADB and ADC both are 90 degree. So that means AD is perpendicular to BC. Similarly, we can prove that BE is also the perpendicular bisector of AC. Now bisector, they are already medians, so they are bisector, and now we have proved that they are perpendicular also. So now we have AD and BE are the perpendicular bisectors of the sides. Now since they are the perpendicular bisectors, so suppose BC and AC are the chords of the circle. We know perpendicular bisectors of the chords pass through the center of the circle. So if we say AD is the perpendicular bisector, so it has to pass through the center, and BE also passes through the center. So they meet or intersect at P, so P becomes the center of that circle. So center of the circle with BC and AC as chords. So thus P is both centroid because it's the meeting point of the medians, and also circumcentric because it's the meeting point of the perpendicular bisectors. In this question we have a figure given. Let us see the figure. So this is the figure. Okay, now let us see the question again. So we have O is the center of the circle, and AB and AC are two equal chords. Okay, so AB and AC are equal, and O is the center, so OP is perpendicular to AB, that is also given, and OQ is perpendicular to AC. We have to prove that PB equals to QC. Now let us see the figure. So in this figure we can see O is the center of the circle. Then we have chord AB and chord AC, both are equal. So half of AB, that's MB, and half of AC will also be equal, that's NC. Okay, so again we have OP and OQ are the radius of the circle, so they're equal. So if we subtract OM from OP, I get MP, and ON from OQ we get NQ. So they are also equal because equal chords are equidistant from the center, and therefore OM and ON are equal. So if we subtract equal parts from the radius, whatever left, that is NQ and MP are equal. And also we have this as 90 degrees, so angle N here, CNQ and BMP, they are 90 degrees. So if we compare triangle PMB and triangle QNC, we can prove they are congruent by SAS congruency, and thus we can say that PB equals to QC. So here you can see the answer. We have OM perpendicular to AB, thus AM and BM both are half of AB because perpendicular from the center bisect the chord. Okay, similarly we have AN and CN half of AC. Also since AC and AB are equal, so BM and CN are equal. Okay. Similarly OP and OQ are equal because they are the radius, and OM and ON are equal because they are the distance of the equal chords from the center. Subtracting we get MP equals to NQ. Okay, they are equal. Now if we see the triangles BMP and CNQ, we can prove them congruent by SAS, and thus PB equals to QC by CPCT, corresponding parts of congruent triangles. In this question we have a figure where a line L intersects two concentric circles at 4 points A, B, C and T. So if you see the circle with green color and the circle with orange color, they this line L intersects the two circles at A, B, C and D. Okay, so we have to prove that AB and CD are equal. This is required to prove. What we are going to do is join all the radii OA, OB, OC and OD. So also we have to draw the perpendicular from O to the line L. So these are the radii for the two circles. OA and OD are the radii of the larger circle, and OB and OC are the radius of the smaller circle. And OP is the perpendicular drawn from O to the line L. The perpendicular will bisect the chord for the smaller circle and for the larger circle also. So PB and PC are equal. Also PA and PD are equal. So if we subtract equal parts from equal parts, what we get left over, AB and CD are equal. The answer to this question can be illustrated with the help of this animation. You can see so this is the solution part. OP is perpendicular to AD, therefore OP bisects AD, and PA equals to PD. Also OP bisects BC, so PB equals to PC. So, and then we subtract the second one from the first one, but we get AB is equal to CD. So that's all for now in this video. We're going to learn few more properties and some more questions from the other exercise in the next class. Thank you.